What if the very way we sense time has always been a kind of partnership between nature and perception, never fixed, always shifting like the surface of a calm lake that changes with wind and light? We may think of time as constant, yet history shows us that our sense of its flow has been woven through culture, through the ways we measure and remember. Now we gently pause with the human sense of time, and how fragile it has always been. For most of our species past, there were no precise clocks, no ticking machines. Time was marked by the rising sun, by the shadows stretching across the ground, by the rhythm of seasons that guided harvest and rest. In this sense, time was less a line and more a circle, repeating, familiar, flowing with the environment. Even when we invented calendars, they did not always agree. Different cultures counted days in different ways. Some followed the moon, others the sun. A lunar month is the cycle from one new moon to the next, about 29.5 days. A solar year, the orbit of Earth around the sun, is about 365 days. The two do not fit together neatly. Societies had to adjust, adding extra days or months, smoothing out the mismatch. This already tells us something important. Our sense of time is not only about astronomy, but also about choice and compromise. Let us pause here. Even our modern clocks, so exact, rely on assumptions. An hour is divided into 60 minutes, a minute into 60 seconds. Why 60? It is a heritage of ancient Babylonian counting systems, based on the number 60 because it is divisible in many ways. So what we call a second is already a cultural decision layered upon a natural rhythm. Today, atomic clocks measure seconds with astonishing precision, based on vibrations of cesium atoms. But even this is just one way to pin down the unpinnable. We now know that seconds can flow differently depending on gravity and speed. A clock on a fast plane, or in orbit, ticks at a slightly different pace than one on the ground. Time, it seems, is not as rigid as we might wish. And so when we look backward, we realize how uncertain the flow of earlier ages must be. We have no records of minutes from the Bronze Age, no seconds from the Ice Age. What we do have are rhythms, festivals timed by solstices, rituals tied to planting seasons, myths that recall a long night or an endless summer. These are not proofs, but they hint that humans have always felt time as elastic, sometimes heavy, sometimes swift. Now we may imagine a quiet thought experiment. Suppose in some distant past the Earth rotated a little faster, and days were shorter. For those alive then, a lifetime might still feel the same length, yet in the scale of cosmic time, more days would have passed. Centuries would hold more sunrises. Now imagine the opposite, the Earth spinning more slowly, days stretching longer. The same span of years would contain fewer mornings and evenings, giving the impression of slower passing. Neither case changes the lived flow of life, yet the measure of time itself alters quietly, beneath awareness. The absence of ancient clocks precise enough to record these changes means we cannot know for certain. But absence of evidence is not evidence of absence. It is enough to recognize that our sense of time is fragile, shaped both by the world and by our tools. The traces we can find are indirect, the language of old records and artifacts. A stone aligned to a solstice may tell us how carefully people once tracked the sun. A record of harvests may suggest how seasons were counted. A legend of a year without a summer preserves memory of volcanic ash dimming the skies. Each of these is a faint imprint, a shadow cast by time onto culture. As we drift further, we see that time as we know it is a tapestry woven from many threads: astronomy, biology, memory, language. No single thread defines it. Together they form the flow we live inside. Whether or not time itself has ever changed its pace, the way we measure and sense it certainly has. So the human sense of time remains a gentle reminder. What feels stable may be shifting, what seems certain may be fluid. We rest with that uncertainty, neither fearful nor final, but simply aware of the subtle rhythms that have always surrounded us. What if the Earth itself holds hidden records of how time has moved, written not in words but in stone, ice, and living growth? When we look deep into the ground, or into frozen cores of ancient glaciers, we are looking at layers that have been slowly deposited over unimaginable spans. Each layer is like a page in a book that no one intended to write, yet it keeps a story nonetheless. Sedimentary rocks, for example, form as grains of sand or silt settle in water, pressed together over thousands or millions of years. These layers pile gently, one upon another, carrying traces of the environment in which they were born. A darker band may speak of floods, a lighter one of calm, shallow seas. In this way, nature has quietly archived the passing of ages. Ice, too, is an archive. In the coldest places, snow has fallen year after year, compacting into thick cores. Inside these cores, bubbles of air remain trapped, tiny capsules of ancient atmosphere. When scientists drill deep into ice sheets, they are, in effect, holding a frozen memory of the Earth's climate. By reading the proportions of gases inside those bubbles, they see rhythms of warmth and cold, repeating across hundreds of thousands of years. It is as if the planet has been breathing slowly, in and out, leaving a trace of its long cycles. Trees leave their own calendars, more delicate but no less eloquent. Rings form as a tree grows through seasons, wide rings in times of abundance, narrow ones in times of hardship. In some forests, tree rings stretch back thousands of years, forming a chain of overlapping lifetimes that let us glimpse droughts, floods, volcanic eruptions. When these records are compared with ice cores and rock layers, patterns emerge. Some rhythms repeat across archives, suggesting a deeper shared clock within the planet. Now we may pause here. What we cannot say with certainty is whether these patterns reflect only climate and geology, or something more subtle. Our records are incomplete. Rocks are eroded, trees decay, ice melts. What survives is always partial, and we must be cautious not to overread the silences between the traces. Yet even with these limits, a picture forms. It is not proof that time itself has changed, but it shows that the pace of Earth's processes has never been fully steady. To explore this gently, let us try a small experiment of imagination. Imagine an ancient ocean where sediments were settling twice as quickly as they do today. Over 1,000 years, the thickness of deposits would suggest more events, more apparent time. Now imagine the opposite, a still ocean where sediments hardly settle at all. 1,000 years might pass, yet the record would seem thin, almost silent. In both cases, the experience of life would remain continuous, yet the geological archive would whisper very different tempos. Over millions of years, these differences compound, shaping the rhythms we can still read. Fossils add another voice to this quiet chorus. Some creatures, such as corals and shellfish, grow in patterns that record daily or seasonal cycles. Under a microscope, their shells reveal fine lines, as if etched by time itself. When ancient corals are studied, they sometimes show more growth lines per year than modern ones, hinting that long ago Earth's days were shorter, and the years contained more of them. This is not a direct measure of time's flow, but it is a delicate marker, suggesting that the rotation of the planet, the very clock of day and night, has shifted with the ages. Now let us hold this thought gently. The geological record is vast, yet it is always open to reinterpretation. Absence of evidence is not evidence of absence. A missing layer may be erosion, not silence. An unusual rhythm in tree rings may be local, not global. Still, the convergence of many traces, rocks, ice, corals, fossils, gives us reason to wonder if time's rhythm has been quietly elastic. We may not be able to say more than this. But even this limited view is enough to remind us that what feels constant in our daily lives may look very different when stretched across the eons. Time, in the language of Earth's records, appears not as a straight line but as a soft weave, shifting, stretching, contracting. Whether this is a true change in time itself or only in the processes we use to measure it remains uncertain. We end here in a gentle pause, aware that the stones, the ice, the trees, and the fossils are all speaking in their own quiet way, offering fragments of a story too large for us to hold all at once. What if the clocks of the ancient world were not built of gears or metal but of stone, water, and shadow, each one reflecting the pace of time in ways that feel unfamiliar to us now? Before the invention of precise mechanical devices, people turned to what surrounded them. The sun, rising and setting, provided a natural cycle. By placing a pole in the ground and watching its shadow move, they could divide the day into sections. This simple tool, called a sundial, transformed light into measurement. Yet even here, time was not fixed. The length of a shadow changes with the season, the latitude, even the shape of the land. A sundial in one place would not match perfectly with another far away. In this sense, time was always local, always tied to the land beneath. Water clocks added another layer. These were bowls or jars that let water drip at a steady pace, marking the passage of moments. But the drip was never truly steady. Cold slowed it, warmth hastened it. A clogged hole made time creep, a wider hole made it rush. These early clocks remind us how fragile our attempts have been to capture something so elusive. Now we may pause for a moment. These devices were not only instruments, they were symbols. They shaped how people lived, when to gather, when to pray, when to rest. In temples and courts, the sound of dripping water or the stretch of a shadow could govern entire communities. Time, then, was not only personal but communal, and the instruments that marked it carried authority. Yet we must be cautious. Many of these devices have not survived in full. What we know comes from fragments, descriptions, or rare examples preserved in dry climate. Absence of evidence does not mean absence of use. It only means that the fragile materials of daily life rarely reach us intact across the centuries. Still, the traces we do hold are telling. An inscription explaining the hours of a sundial. A vessel with markings along its side, perhaps for water flow. These small artifacts are quiet voices across time, telling us how carefully people tried to hold the unholdable. Let us imagine gently how these tools might have shaped perception. If the sundial's shadow stretched differently in summer and winter, people may have felt that days themselves carried different rhythms, longer or shorter, heavier or lighter. If a water clock's flow slowed in cold nights, time itself may have seemed sluggish, almost drowsy. Across generations, these impressions could become part of culture, part of myth, perhaps even part of how memory recorded the past. Now a soft thought experiment. Suppose an ancient city relied only on sundials. In summer, days appeared long with many divisions. In winter, the same sundial showed fewer clear sections. Over years, the culture might grow to see summer as expansive, filled with more opportunities, while winter felt compressed, fleeting. Now imagine a society relying on water clock. During drought, the drip slowed, stretching days into something heavy. During humid warmth, time quickened, full of restlessness. Neither device was precise in the modern sense, but both shaped perception. Over centuries, such subtle shifts may have influenced how history itself was told. We cannot know this with certainty. Our evidence is scattered and incomplete. But these artifacts and their traces remind us that time has always been something filtered, never pure. The mechanisms we build to mark it are like lenses, each distorting slightly, each leaving behind a record of its distortions. When we look at them today, we are not only seeing devices but also glimpsing the way entire communities once felt time's flow. The lesson is gentle. Time has always been entwined with matter, climate, and culture. Early clocks show us that even the act of measurement is fragile, dependent on environment. Whether shadows or drops, the rhythm was never steady. And so we rest with this thought. What seems like the steady beat of time may have always been a collection of uneven, local pulses, stitched together into the illusion of continuity. What if the passage of time has always been felt not only through clocks and calendars but also through our own bodies, each of us carrying within a quiet metronome that responds to light, food, and the slow cycles of the earth? Every living being holds rhythms, patterns of repetition that give structure to life. In humans, this rhythm is often called the circadian cycle, a natural day-night loop tied to the rising and setting of the sun. When morning light reaches our eyes, chemical signals tell our body to wake. As evening comes, another set of signals invites us to rest. It is a delicate dance, as simple and dependable as breathing, yet also open to subtle shifts. Now we may pause here, because these rhythms are not unique to us. Plants open their leaves in daylight and fold them in darkness. Flowers bloom at certain hours, closing again as shadows lengthen. In the ocean, tiny plankton rise toward the surface each night and sink with the dawn, following a rhythm older than human memory. These patterns show us that time is not only something measured outside, it is something lived within. The mechanisms are biological, but they are also fragile. A small change in light or temperature can shift the cycle. Traveling across continents, we notice how our inner clocks struggle to adjust, giving us jet lag. Imagine, then, how different climates, longer days near the poles, or ancient shifts in Earth's tilt could have gently adjusted these rhythms over centuries. We do not know precisely how organisms of the past felt time. Fossils do not preserve sleep, hunger, or hormonal cycles. Yet indirect traces remain. Growth rings in bones, shells, and trees show that cycles have always been present, though sometimes with different lengths. Coral fossils, for example, reveal that long ago Earth spun faster, giving more days to a year. If days were shorter, then circadian rhythms may also have been tuned differently, perhaps making nights feel briefer, dawns more frequent. Here we must be careful. These inferences are fragile, and we cannot confirm them with certainty. The absence of direct evidence does not mean that these shifts did not happen. It simply shows the limits of what archives can hold. Still, the language of traces is suggestive. Repeating bands in ancient shells, layered deposits in lake sediments, and even the chemistry of old teeth preserve hints of growth and rest, feast and scarcity. Together they form a mosaic of repeating patterns, markers of time as lived through biology. Let us imagine gently how life would unfold if Earth's rotation had been slower in earlier ages. Longer days would stretch the waking period of plants and animals. Flowers might bloom for hours longer. Predators and prey would move under extended light, while nights would invite deeper, slower rest. Over thousands of generations, bodies would adjust, building new rhythms. Now imagine the opposite, a quicker rotation with shorter days. Life would need to hurry, blooming and feeding in briefer windows, sleeping in shorter spans. The sense of a day might feel compressed, perhaps making lives feel faster, though no less full. In both thought experiments, the flow of life adapts. Time itself may not change, but the rhythms of living things bend with their environment, leaving faint imprints for us to notice millions of years later. These possibilities remind us of a gentle truth. The sense of time we carry is not only cultural but also biological, tied to light and cycles beyond our control. Whether ancient days were longer or shorter, whether climates shifted gently or abruptly, living beings always adjusted, shaping their own clocks to the world around them. This is not a conclusion but a pause, an open recognition that our own heartbeat, our own sleep, our own sense of days and nights are part of a larger, older fabric of rhythms. To listen to them is to sense time not as a rigid ruler, but as a quiet music, changing tempo with the ages, yet always flowing onward. What if the flow of time on Earth has always been influenced by forces far beyond our atmosphere, forces that turn slowly and steadily, shaping the rhythm of days and nights without us noticing? Our planet is not a solitary island, but part of a larger system. It spins on its axis, tilted slightly, while orbiting the sun. Around it moves the moon, pulling at the oceans with quiet persistence. These motions create cycles that are familiar to us, yet they are not fixed. Over vast stretches of time they shift, almost imperceptibly, leaving behind long trails of evidence. The Earth's rotation, for instance, is gradually slowing. Each day lengthens by tiny fractions of a second, too small for us to feel but measurable when compared across millions of years. The mechanism is simple yet profound. The gravitational pull of the moon tugs at the oceans, raising tide. These tides drag against the Earth's rotation, like a hand gently slowing a spinning wheel. Energy transfers to the moon, nudging it farther away. The result is a gradual stretching of the day. What we call 24 hours now was once shorter, perhaps 22 hours in deep prehistory, and even less in earlier epoch. Fossil corals offer a quiet testimony. Their growth rings, similar to those of trees, reveal daily and yearly patterns. When examined under microscopes, ancient corals show that hundreds of millions of years ago a year held more days, because each day was shorter. These natural archives, built by small living creatures, record the slow evolution of Earth's spin. The moon itself moves away by about the width of a fingernail each year. That gentle drift changes the rhythm of tides and the length of days, showing us that cosmic influences are not abstract ideas but lived processes written into the fabric of our world. Now we may pause. These findings do not prove that time itself changes, only that our measures of days and years are not constants but evolving markers. The mechanisms are well understood, yet the details are filled with uncertainty. Fossil evidence is uneven, sometimes eroded or incomplete. Geological layers may mislead, shaped by local conditions. The absence of perfectly continuous records leaves space for caution. Still, the convergence of data from many sources, corals, sediments, astronomical models, creates a strong pattern, one that whispers of time stretching softly through the ages. Let us imagine gently what it might mean. If days once passed more quickly, with more of them in each year, life may have unfolded under a faster rhythm. Creatures might have grown accustomed to shorter nights, more frequent dawns, quicker tides. Over long spans, evolution itself may have been nudged by these subtle shifts, shaping behaviors and lifespans. Now imagine the future, where days continue to lengthen as the moon drifts farther. Nights may someday stretch longer, tides gentler, the planets spin slower. Though imperceptible to us now, the accumulation over billions of years could transform how Earth feels time. Yet we may never reach that distant horizon, and so we hold the thought lightly, as a possibility more than a prediction. The language of traces remains our guide. Fossils, tidal sediments, astronomical models all speak in different dialects, yet together they form a soft chorus. They remind us that cosmic influences are not sudden shocks but slow, enduring movements weaving through the history of Earth. Our awareness of them is young, our measurements brief, and we must remain humble. Absence of evidence is not evidence of absence, and every trace we find is partial, shaped by chance survival. The open question remains: do these shifts mean that time itself has changed, or only that our earthly markers are not as steady as we once thought? We may never know with certainty. What we can know is that the universe moves slowly around us, and that its motions leave faint imprints on the rhythm of our days. To sit with that knowledge is to feel time not as a rigid clock but as a soft tide, shaped by forces beyond our reach, flowing quietly onward. What if the quiet language of fossils could tell us not only about life long vanished, but also about the tempo of days and years in which that life once unfolded? When we look closely at the preserved remains of ancient corals, shells, or stromatolites, we are not only seeing shapes of creatures but also patterns that carry the memory of cycles. Many organisms grow in increments, laying down tiny layers each day, like lines in a diary. Over longer spans, these lines gather into annual bands, much like the rings of trees. By counting them, we can glimpse how many days once filled a year. And here a subtle discovery arises. Fossil corals hundreds of millions of years old show more daily growth lines per year than modern corals. This suggests that the Earth rotated faster, that days were shorter, and that a year contained more of them. Now we may pause and let this thought settle. The world of those creatures was lit by the same sun, yet their dawns came more often. Their years were measured not by the number of days we know, but by a faster rhythm. For them, time's fabric may have felt slightly different, even if they never noticed it. The mechanism is simple. As the moon pulls on the tides, it slowly steals momentum from Earth's spin, making days lengthen. This process is steady, but its traces are delicate. Corals, with their patient growth, recorded it without intent. In their skeletons, still preserved in stone, we can read the tempo of a living world from hundreds of millions of years ago. Yet we must be cautious. Not all fossils are well preserved, and not all patterns are clear. Erosion can blur lines, chemical changes can alter structures, and local conditions may mislead. The absence of growth rings in some fossils does not mean days were unchanging. It may simply mean that the record did not survive. Absence of evidence is not evidence of absence. Still, when many fossils from different places and times show similar rhythms, a picture begins to form. The language of traces is quiet but consistent. Corals show more days in a year long ago. Stromatolites, layered mats of microbes, show repeating bands that also hint at cycles tied to shorter days. Even ancient tidal sediments whisper the same story, with patterns suggesting more frequent tides in Earth's past. Now let us try a gentle thought experiment. Imagine standing on a shoreline 300 million years ago. The sun rises and sets more quickly. A year still passes as Earth orbits the sun, but instead of 365 sunrises, there are more than 400. Seasons follow one another as they do today, yet each season is divided into more days. For life, this means rhythms of feeding, resting, and growing unfold in slightly shorter units of time. Over millions of years, these faster days shape the pace of ecosystems, perhaps even influencing the evolution of species adapted to cycles of light and dark. Now imagine the slow future. The Earth keeps spinning, but ever more slowly. Days lengthen. Hundreds of millions of years ahead, a year may hold only 300 days, then fewer still. Nights may stretch longer, tides grow weaker. If creatures are still here, their rhythms will adjust as ours once did. This is not something we will witness, but the fossils we leave may whisper the story to beings that come long after us. The fossil record teaches us humility. It does not give us certainties, only quiet suggestions. It shows that what we take as constant, the length of a day, the rhythm of a year, has shifted with the ages. The difference is slow, far beyond our daily senses, but written patiently into the growth of corals, shells, and microbial mats. Each fossil is like a time capsule, carrying not only the form of life but also the measure of its world. To rest with this knowledge is to feel the vastness of time itself. Days and years, so firm in our experience, are not eternal measures. They are flexible, stretching and contracting under cosmic influences, leaving traces for us to discover. And so we end with an open thought. Perhaps what we call time is not a single, steady stream, but a river with shifting currents, recorded in the most delicate of fossils, waiting for us to listen. What if myths, legends, and old stories are not only products of imagination but also faint reflections of how people once felt the rhythm of time itself? Across many cultures we find tales of long nights, golden ages, or eras when gods and humans lived at different speed. These stories may not be scientific records, but they are archives of perception, shaped by memory and passed through generations. They tell us how communities sensed cycles of day, season, and history long before precise instruments existed. Now we may pause and listen to these voices. In Greek tradition, there are ages named for metals: gold, silver, bronze, iron, each with its own tempo, its own atmosphere of time. In the age of gold, life was said to be slow and harmonious, without toil or rush. Later ages felt faster, harsher, filled with effort. Whether myth or metaphor, this layering of ages shows that people once thought of time as uneven, unfolding in stages rather than a steady flow. In the myths of the North, we find stories of a long winter before renewal, a cycle of dark stretching before light's return. Elsewhere, stories of endless summers or days when the sun stood still echo through oral traditions. Such memories may have grown from unusual natural events, volcanoes, shifts in climate, or rare astronomical alignment. Yet even if rooted in real events, the telling transformed them into patterns of time, woven into human culture. Now we should linger briefly on what this means for us. These tales are not evidence that time itself changed, but they are markers of how fragile and elastic the sense of time has always been. A season of famine might feel endless. A sudden storm might make a night seem stretched. Over centuries, these impressions become mythic, carrying the feeling of altered rhythms. The limitation is clear. We cannot know whether such stories reflect real cosmic or geological changes, or whether they are human responses to hardship and wonder. Oral tradition shifts with each retelling. What began as memory may become symbol, and what began as symbol may be read as history. Absence of direct evidence means we cannot draw hard conclusions. Still, the persistence of such motifs across different cultures suggests that humanity, in many places, has felt the flow of time as uneven. The language of traces appears not only in rocks or fossils, but in myths as well. Myths are not precise, but they are durable. They carry ideas across centuries, even millennia. When stories of long nights appear in regions that once experienced volcanic ash dimming the sun, we notice a faint resonance. When ages of gold are recalled during periods of favorable climate, we see another alignment. These connections are fragile, yet they whisper of links between perception and environment. Let us attempt a quiet thought experiment. Imagine an ancient community living through years when winters grew colder and longer, when crops struggled. For them, time might feel slower, heavier, each day burdened by scarcity. Generations later, their descendants might tell stories of a great dark age when the world itself slowed. Now imagine the opposite. A stretch of years with abundant harvests, gentle climate, and long summers. Time in such an era might feel rich, flowing easily. In memory, this becomes an age of gold, not because clocks changed, but because life felt full and light. In both cases, myth becomes the vessel of time's rhythm, carrying the impression of its flow beyond the reach of instruments. These possibilities remind us to treat myths not as literal records but as signals of human perception, archives of how time felt in the heart of communities. They are like fossils of memory, shaped not in stone but in story. They remind us that the experience of time has always been layered, biological, cultural, cosmic. We may never know how much of myth reflects external shifts and how much arises from within. But to sit with these stories is to acknowledge that our ancestors, too, grappled with the mysteries of time's uneven rhythm. And so we rest with an open thought, that the human imagination, through myth, preserves another kind of archive of time, one made not of stone or ice, but of words and wonder, still echoing softly through the ages. What if physics, with all its precision and elegance, only shows us a narrow window into what time truly is, leaving vast regions of mystery untouched? In our everyday lives, we sense time as something that flows in one direction, carrying us gently forward. Yet in the language of equations, time appears less certain, less rigid, almost symmetrical. The great theories of physics often treat time not as a river but as a coordinate, like length or width, something to be measured but not necessarily experienced. Now we may pause here and soften our focus. In Newton's vision, time was absolute, ticking everywhere in the universe at the same pace, like a vast invisible clock. Later, Einstein showed us another picture, where time is not fixed but bends under the weight of motion and gravity. A fast-moving object experiences time differently. A clock on a mountain ticks slightly quicker than one at sea level. These effects are too small for our senses, but they can be measured, and they reveal that time is not uniform across the cosmos. Still, even these discoveries leave us with uncertainties. The equations of relativity allow time to run forward or backward, yet our lived experience only knows the forward flow. Why this is so remains one of the quiet puzzles of physics. Now let us linger on the limits of this knowledge. Our instruments can measure tiny differences in time, but they cannot tell us why time feels as it does, why it seems to move with a direction. Quantum theory adds another layer of complexity, showing us a world where probabilities replace certainties, where the past and future may not be as clearly divided as we think. Absence of proof is not proof of absence. The fact that we cannot yet explain the essence of time does not mean there is nothing to be explained. The language of traces in physics comes not from fossils or sediments, but from data, from experiments that repeat with slight variations, from particles that behave in ways we did not expect. These traces, though indirect, suggest that time is deeply woven into the fabric of reality, but perhaps not in the steady way we assume. A gentle thought experiment may help us here. Imagine if time truly had no preferred direction. For us, the future is always opening and the past always closing, but suppose that at some deeper level they were symmetrical. Life would still unfold as it does, because entropy, the tendency of order to break into disorder, would still guide the arrow we experience. Yet perhaps in distant corners of the cosmos, or under conditions we cannot yet reach, the flow might look different. Now imagine another possibility. What if time itself is not continuous but granular, made of the smallest indivisible units, as some theories propose? For us, it would still appear smooth, just as a film appears smooth though it is made of many frames. But on a deeper scale, time could tick in quanta, leaving faint imprints in the behavior of particles. If such imprints exist, they are too subtle for us to fully capture now. These experiments of imagination do not solve the mystery, but they show how fragile our understanding is. We may be living inside a framework of time that is broader than our equations reveal. We cannot say this with certainty, but to hold the possibility gently is to open space for wonder. Physics has given us tools to measure, models to predict, and insights to explore, but it also shows us the limits of our perception. The story of time in physics is one of elegance and incompleteness, a reminder that even in the most rigorous sciences, uncertainty remains. To rest with this thought is to accept that time, whether a dimension, a flow, or something beyond our current language, continues to move quietly around us, carrying both our lives and our questions forward in its patient rhythm. What if the flow of time on Earth has quietly shifted under the influence of relativity, not in dramatic leaps but in the smallest of differences that accumulate over ages? Einstein's insight showed us that time is not absolute. It bends with motion and with gravity. A clock moving quickly will tick differently than one at rest. A clock deep in a valley, closer to the pull of the Earth, will run more slowly than one on a mountain peak. These variations are invisible to our senses, yet they are real, measurable with the delicacy of modern instruments. Now we may pause and picture the Earth not as a single steady sphere but as a varied surface, where mountains, oceans, and deep caves all create slightly different rhythms of time. Each region carries its own tiny pace, shaped by gravity and motion. In our daily lives this makes no difference, yet on the scale of millennia, perhaps such subtle variations leave traces. The mechanism is gentle. As the Earth spins, points on the surface move at different speeds. At the equator, motion is fastest, near the poles, slower. According to relativity, these changes in speed adjust the passage of time ever so slightly. A second in one place is not quite the same as a second in another, though the difference is so small that only atomic clocks reveal it. The question is whether these countless minor variations, persisting over millions of years, may have shaped the records we now study. We cannot know this with certainty. The evidence is indirect. fossil growth rings, tidal sediments, layers of ice. These preserve rhythms, but they do not tell us whether relativity had a hand in them. Our instruments have existed only for a short while, and so our baseline is brief. Absence of direct proof does not mean the absence of effect. It only shows us how cautious we must be when extending present knowledge into deep time. Now let us linger with a thought experiment. Imagine an ancient landscape with towering mountains. Creatures living at the summit experience time just a little faster than those in the valley below. For them, life feels the same, yet if we could compare their clocks side by side across millennia, differences would accumulate. Now extend this thought outward. Imagine Earth itself in motion around the Sun, and the Sun orbiting within the galaxy. Each path creates conditions where time stretches or contracts. The differences are faint, but over cosmic spans they might weave patterns into the archives of fossils, sediments, or even planetary rotations. These possibilities remind us that time is not only shaped by the Earth's spin or the Moon's pull, but also by the fabric of space-time itself. The traces are not easy to read. They do not appear as clear lines in stone but as subtle mismatches, irregularities in cycles that otherwise seem steady. We cannot yet distinguish whether such irregularities arise from geology, biology, or relativity. But to consider them is to widen our sense of how many factors have quietly sculpted the tempo of Earth. A gentle conclusion arises. Relativity tells us that time is not uniform, but its effects on Earth are too subtle for us to map fully across history. What remains is the awareness that the flow of time may never have been perfectly even in the smallest measure. To sit with this thought is not to seek certainty, but to rest in the quiet knowledge that time, like light or gravity, belongs to the vast structure of the universe. It carries us softly, bending in ways we cannot always see, leaving faint traces that whisper but do not declare. What if the flow of time on Earth has been shaped not only by its rotation and the pull of the Moon, but also by the weight of its own shifting body? Our planet is not a perfectly still sphere. Its mass moves, mountains rise, oceans shift, glaciers grow and melt. With each change, gravity is redistributed. And according to relativity, gravity bends time ever so slightly. A stronger gravitational pull makes clocks run a little slower, a weaker one lets them run faster. These differences are far too small for us to notice, yet over immense spans they may leave faint traces in the archives of Earth. Now we may pause to picture the mechanism in simple words. Imagine a clock placed deep underground, where gravity presses strongly. It will tick just a little more slowly than the same clock placed high on a mountain peak. The difference is measured in billionths of a second, invisible to daily life. But across millions of years, as continents drift, seas deepen, and ice sheets come and go, Earth's gravity field is reshaped. Time, in these subtle ways, may have flowed unevenly across places and epochs. The evidence is indirect. We do not find fossils that declare, time was slower here. What we find are small mismatches. Growth rings in ancient shells that suggest rhythms not quite the same as today. Tidal sediments that seem compressed or stretched. Geological layers that carry cycles not perfectly aligned with modern ones. Each of these could have many causes: climate, chemistry, local environment. But woven together, they invite the thought that Earth's own weight has softly bent its clock. Let us stay with this thought a little longer. During the ice ages, vast sheets of ice covered continents. Their weight pressed the crust downward, increasing local gravity. In such regions, time would have flowed a fraction more slowly than in places without that burden. When the ice melted, the crust lifted, and the balance shifted again. None of this altered the lives of those who walked those landscapes. Their days still began with dawn and ended with night. But if we imagine the silent ticking of nature's deepest clock, we see how uneven the rhythm might have been, hidden under the surface. Now we can try a gentle experiment of imagination. Suppose we lived in a world where massive volcanic eruptions covered a continent with heavy layers of rock. In those regions, gravity would increase slightly, and the flow of time, measured with impossible precision, would slow a little. Across thousands of years, the archives of shells and corals might record cycles that appear subtly off from those far away. Now suppose the opposite. Great oceans deepen as tectonic plates move. Water replaces landmass, and the pull changes in another way. Clocks, if they had existed, might have ticked faster in those lighter regions. Over geological time, these small differences could accumulate into traces we may glimpse but never fully resolve. What we cannot know is the true scale of these effects. Our instruments, though precise, have only measured for a brief moment in Earth's history. We cannot replay the deep past with such clarity. The archives we study, fossils, sediments, isotopes, speak in whispers, not in declarations. Absence of clear proof does not mean these influences were absent. It only reminds us of the vast distance between what happened and what can still be read. The cautious conclusion is that time on Earth has likely been uneven in ways too delicate for us to feel, shaped by the planet's own shifting mass and gravity. For us, life has always flowed as a continuous stream, unbroken, familiar. Yet beneath that stream, the invisible fabric of time has bent and stretched with the slow breathing of Earth itself. To hold this thought is not to seek certainty, but to rest in the awareness that even the simplest measures, a second, a day, are woven into a universe that is never fully still. Time, like the planet it belongs to, is alive with gentle changes, too subtle for us to grasp, yet patient enough to leave traces in stone, ice, and memory. What if light itself, so constant in our understanding, quietly reveals that time may not have always flowed as we assume? In physics, the speed of light in a vacuum is treated as a fixed measure, a kind of ultimate clock that sets the rhythm of the universe. Yet the path of light is rarely pure. It bends, slows, or scatters when passing through dust, gas, or the pull of gravity. When astronomers study the faint glow of distant stars and galaxies, they are not looking at the present but at messages from deep time, signals that have traveled for millions or even billions of years before reaching us. These beams of light carry within them the imprint of space stretching, of gravity bending, of matter shifting, and perhaps of time itself unfolding differently across the vastness. Now we may pause and let this settle. To us, light feels instant. We flick a switch and the room brightens. But across cosmic scales, light is a patient traveler. When it leaves a star, it can be bent by the gravity of other stars, smeared by dust, or stretched by the expansion of space. This stretching, called redshift, turns light toward longer, redder wavelength. It is a signal that the universe itself has been expanding, and with it, perhaps, the rhythm of time has been stretching as well. The mechanism is not difficult to imagine. If space grows, the waves of light grow too, as though pulled gently apart. A second measured from the flicker of a distant star may not match a second measured here. Over billions of years, these differences compound, leaving us to wonder whether time, like light, is elastic on the largest scales. The evidence is indirect, carried in spectra, the fingerprints of elements seen in starlight. By comparing these patterns with those measured in laboratories, scientists infer how much the light has shifted. This is our language of traces in the sky, not carved in stone but written in beams that crossed unimaginable distances. Still, there are limits. We do not know if light has always behaved in exactly the same way. The constants we rely on may themselves be part of a story larger than we can yet grasp. Absence of proof of change does not mean that change has never occurred. It only reminds us of the narrowness of our view. Let us try a gentle thought experiment. Imagine standing on Earth billions of years ago, under skies where galaxies were closer and light had traveled less distance to reach us. If the fabric of space was tighter, perhaps seconds felt shorter, days more compact, though life would not notice. Now imagine the far future, where the expansion has stretched galaxies even farther away. Light will arrive more diluted, more red, carrying slower rhythms. For those who live then, time may still feel steady, but the cosmic backdrop will suggest otherwise, whispering of stretched seconds and elongated days. In both cases, our lived sense of continuity remains, but the larger stage hints at a rhythm that is not fixed but evolving. The cautious conclusion is that light, by carrying the memory of its journey, shows us that time may not be as uniform as our daily clocks suggest. We cannot claim with certainty that time itself has changed. What we can say is that the messages from the cosmos, redshifts, distortions, faint echoes, remind us that the measure of a second here is not always the same as a second far away or long ago. To rest with this thought is to feel a quiet humility. Our clocks are local, our lifespans brief, yet the universe moves on scales where even light bends and stretches. Time, seen through the language of light, is not a rigid ruler but a gentle, elastic thread, carrying whispers of change across the darkness of space. What if the monuments of stone and earth, built long before our instruments, were not only places of worship or gathering, but also delicate tools for listening to the rhythm of time? Across continents we find ancient structures aligned with the movements of the sun, the moon, and the stars. Circles of stone, pyramids, temples, each placed with care so that light would strike a chamber at sunrise on the solstice, or the moon would appear through a narrow gap at a certain phase. These alignments were not accidents. They reveal that people were watching the heavens, counting cycles, and anchoring their sense of time in the dance of light across the sky. Now we may pause and consider the scale. These monuments do not measure seconds or minutes, but the longer breaths of the year. A solstice marks the longest day, an equinox the balance of light and dark. By fixing stone in alignment with these events, ancient builders created clocks of great patience, ticking only twice a year yet holding meaning for centuries. In this way, architecture became an archive of time, one that has survived long after the cultures that raised it faded. The mechanism is simple to imagine. A shaft of light enters a chamber only when the sun is at a particular position. Year after year, the beam returns like a promise renewed. If the alignment shifts slightly, it suggests that either the monument has settled or the heavens themselves have drifted. Here we meet an uncertainty. We do not always know whether these structures were designed with the precision we now attribute to them, or whether later interpretation has added meaning. Some alignments may be coincidence, some intentional. Absence of clear written records leaves us cautious. But the persistence of patterns across many places hints at something deliberate, a widespread desire to anchor human life to celestial rhythms. The language of traces here is not fossils or ice, but stone and shadow. An opening in a temple that floods with light only on the solstice. A stone circle that frames the rising of a particular star. These are quiet records, carved not in numbers but in experience. They tell us that long ago people already sensed the unevenness of cycles, already sought ways to keep time steady through the heavens. Let us imagine gently. Suppose we are part of a community that gathers at dawn on the shortest day of the year. As the sun rises, it shines directly through a narrow passage of stone, illuminating the chamber within. For us, this moment confirms that the cycle has turned, that light will slowly return. Now imagine centuries later. The same monument still stands, but the alignment is no longer perfect. Perhaps the tilt of Earth has shifted slightly, or the monument has settled. The moment feels off. For those who gather, this could suggest that time itself has bent, that the heavens are not fixed but drifting. Across ages, such experiences may have shaped myths of changing worlds, of shifting eras. They are not proof of time itself changing, but they are markers of how people perceived rhythms far larger than daily life. We must acknowledge the limit. Stone endures, but intention does not. Without voices from those builders, we cannot know exactly what they sought. Yet the alignments remain, silent but insistent. They remind us that time has always been measured not only in seconds but in light and shadow, in cycles of sky and season. To rest with this thought is to see these ancient calendars as part of a much larger conversation between Earth and cosmos. Whether or not time itself has flowed differently, humans have long felt the need to anchor it, to listen for its patterns, and to leave behind monuments that continue to whisper of rhythms beyond their own lives. What if ice itself, clear and silent, has been holding a memory of time's rhythms far longer than any human record? Deep beneath the frozen surfaces of Greenland and Antarctica lie vast cores of ice, each layer pressed by centuries of snowfall. Within those layers are tiny bubbles of ancient air, crystals of frozen water, and faint traces of volcanic ash. Together they form one of the most delicate and enduring archives on Earth. By studying these layers, we can glimpse how climate and atmosphere have changed, and perhaps notice whether the flow of time has ever carried a different pace. Now we may pause and imagine the mechanism in simple terms. Each year, snow falls, compresses, and becomes part of the ice sheet. Light summers leave lighter bands, dark winters leave denser layers. Volcanic eruptions scatter ash that settles into a distinct marker. Dust from deserts or pollen from distant plants travels on winds and is locked into the ice. Layer upon layer, year after year, the record builds. It is like a vast library with no words, only pages of compressed seasons. Scientists read these pages by drilling long cylinders of ice, sometimes more than 3 kilometers deep. The oldest cores reach back hundreds of thousands of years, perhaps close to 1 million. When the air trapped inside is measured, we can see the rise and fall of carbon dioxide, the breath of the planet across ages. We can also trace temperature through the chemistry of the ice itself, noticing cycles of warm and cold that repeat like the slow inhale and exhale of Earth. Here we encounter a quiet uncertainty. These records are powerful, yet they are not perfect. Layers thin and blur with depth. Pressure distorts them. Some years vanish, compressed into silence. Absence of clear markers does not mean absence of event. It only shows us the limits of preservation. Still, even through this uncertainty, patterns appear. Cycles of glaciation and interglaciation, repeating with a rhythm tied to Earth's orbit and tilt. Sometimes the cycles seem stretched or compressed, as though time itself breathed unevenly. Whether this is a reflection of climate alone or of something deeper, we cannot fully know. Now we can linger with a gentle thought experiment. Imagine that the pace of Earth's rotation changed slightly during an ancient epoch. Days grew longer, the number of them in a year fewer. For life, the adjustment would be seamless. Yet in the ice, the cycles of dust and gas would stretch differently. When read today, they might appear as subtle anomalies, places where time seems to flow unevenly. Or imagine another possibility. Suppose that the expansion of space itself shifted the rhythm of sunlight reaching Earth, not in brightness but in timing. Over long ages, this would imprint itself into the ice as irregularities, layers that feel offbeat compared to the regular cycle we expect. We cannot claim this happened, but such thought experiments remind us that ice does not only archive climate, it also archives rhythm. The language of traces here is fragile but eloquent. Isotopes of oxygen in the ice tell us about ancient temperatures. Layers of ash tell us of eruptions that once darkened skies. Bubbles of air tell us of atmospheres long gone. Each is a marker, a signal that time has been layered, compressed, and preserved in a form we can still hold in our hand. The conclusion must remain cautious. Ice cores do not prove that time has changed, but they show us that the flow of Earth's processes is never perfectly steady. Climate warms and cools, layers stretch and thin, rhythms shift. To rest with this knowledge is to accept that even the quietest archives are full of uncertainties, yet still they whisper of cycles larger than us. Time, as seen in ice, is not a rigid march but a series of breaths, uneven yet enduring, frozen into silence until we learn to listen. What if the oceans, so vast and restless, are not only waters that shape our coasts but also ancient clocks that have kept track of time for billions of years? Their tides, pulled by the moon and the sun, are among the oldest rhythms on Earth. They rise and fall with quiet persistence, marking cycles that creatures have followed long before any calendar was made. Each wave is temporary, yet the pattern endures, carrying within it the history of Earth's slow changes. Now we may pause and look more closely. The tides are caused by the gravitational pull of the moon, assisted by the sun. When the moon is close and aligned with the sun, tides grow stronger, called spring tide. When the moon and sun are at right angles, tides weaken, called neap tides. This rhythm is familiar, repeating every day, every fortnight, every month. Yet, over immense time, it has shifted. The moon is slowly moving farther away, a few centimeters each year. As it drifts outward, its pull weakens and the tides grow gentler. At the same time, Earth's rotation slows, making days longer. These two processes are connected, parts of one long exchange of energy between planet and satellite. The mechanism is subtle but clear. As tides move across the oceans, friction between water and land drags against Earth's spin, stealing a tiny fraction of momentum. This lost energy is transferred to the moon, pushing it outward. The result is a double change. The moon grows more distant and the Earth rotates more slowly. To us, the difference is invisible. But in the language of traces, it is written in stone. Ancient tidal sediments, preserved as ripples in rock, reveal that hundreds of millions of years ago the cycle of tides was faster. Fossil corals show more daily growth rings per year, meaning that days were shorter and years contained more of them. These are indirect but consistent markers, a geological diary of time's quiet stretch. Now we may linger with a thought experiment. Imagine standing on a shore 600 million years ago. The moon hangs larger in the sky, closer than it is today. The tides rise and fall more strongly, perhaps several times each day. The sun still completes its yearly cycle, but each day is shorter, giving more sunrises and sunsets in a year. Life in the shallow seas grows under this rapid rhythm, adjusting to tides that come and go more quickly. Now imagine far into the future. The moon has drifted farther still, and the tides are weaker, slower. Days on Earth have stretched longer. Creatures of that time, if they exist, live under a different rhythm, where the beat of the tide is fainter and the measure of a day is broader. To them it feels natural, as it does to us now. Yet when they look back through records, perhaps they too will see that the tempo was never constant. Here we must be careful. Not every ripple preserved in rock is a perfect record of tide. Local conditions, storms, and currents leave their marks too. The absence of certain patterns does not mean tides were absent. It only shows how fragmentary the record is. Still, when many sources agree, sediments, corals, astronomical models, they build a quiet but convincing case. The oceans, in their restless movement, have been measuring time all along. The cautious conclusion is that tides remind us of time's elasticity. Not because time itself must change, but because the measures we use, days, years, cycles, are bound to Earth's spin and the moon's pull, both of which shift across ages. To rest with this thought is to sense the deep patience of the planet. The seas move in and out, marking moments that accumulate into millennia. What feels steady to us is, in truth, a rhythm that stretches gently, a tide within time itself. What if our sense of time is not only written in stone and stars but also carried quietly within human history, shaped by the way we measured, remembered, and lived through it? For much of our past, life unfolded without clock. Time was marked by natural cues. The call of a bird at dawn, the lengthening of shadows at noon, the fading of light into evening. Communities moved with these rhythms, planting with the seasons, harvesting with the sun's decline, resting when darkness returned. Days were not divided into equal slices but into tasks and event. A journey might be, as long as the sun is high, a pause until the shadow reaches the door. Time was circular, bound to the cycles of nature. Now we may pause and notice a shift. As societies grew, calendars appeared. The movement of the moon offered months, the turning of the earth around the sun gave years. Yet the two did not align neatly. To keep order, extra days or months were added, adjustments made. This was not only a matter of astronomy but also of culture, negotiation, and memory. Different civilizations counted differently, and so the rhythm of life was not uniform across the world. Time was already elastic, bending with human choice. Later, with the rise of mechanical clocks, time became something stricter. Bells in monasteries marked the hours of prayer. Towers rang out across cities, calling people to work, to markets, to worship. A new rhythm emerged, less tied to the sun and more tied to machinery. The day was no longer just dawn to dusk, but divided into measured units, binding communities to shared beat. In this way, time became not only natural but social, a fabric woven across human lives. Yet we must be cautious. The evidence of how people truly felt time is limited. We read fragments in records, inscriptions, diaries. Absence of direct testimony does not mean absence of experience. What survives are indirect markers. Schedules carved into temple walls, logs of hours kept on ships, stories of long winters or fleeting summers. These are not precise, but they show us how perception of time shifted with tools, habits, and needs. Now let us try a gentle thought experiment. Imagine a village without clocks, where each day is guided by the sun. A child grows up with no sense of minutes, only of morning, midday, and night. For that child, time feels fluid, shaped by tasks and seasons. Now imagine a city centuries later, where clocks strike every hour. The same child, born there, lives by schedules, learning to wake at 6, to work by 9, to eat at noon. The flow of life becomes segmented, the day a chain of equal parts. The lived experience of time is different, even if the earth spins in the same way. Finally, imagine our present, where digital clocks count seconds with relentless precision. Notifications mark not only hours but moments. Time feels faster, denser, filled with divisions. Has time itself changed? Perhaps not. But the way we sense it surely has, and that too is a kind of transformation. The lesson is gentle. Human history shows us that time is not only a physical measure but also a cultural one. It stretches or contracts depending on how we live, how we count, how we remember. Whether or not the flow of time itself has shifted, the perception of it has always been fluid, adapting with our tools and ways of life. To rest with this thought is to see that our own clocks are not absolute but one layer in a long story, where the rhythm of life has always been more than just the ticking of hands. What if the greatest lesson of time is not hidden in what we know, but in what we cannot know with certainty? When we speak of time on Earth, we often turn to rocks, fossils, ice, or stars. These are long-lasting witnesses, but even they are incomplete. Layers erode, memories fade, instruments fail. The archives we rely on are never whole. They are fragments, stitched together across gaps. What remains to us is a patchwork, a quiet fabric with more spaces than threads. Now we may pause and soften our focus on these absences. Science often moves forward by piecing together what is left, but silence is also part of the story. A missing section in an ice core, a gap in sediment, a broken sequence of fossils. Each reminds us that what we see is partial. Absence of evidence is not evidence of absence. It only tells us that the record is fragile, that nature's memory is incomplete. Let us linger for a moment with the way these gaps shape our understanding. Imagine we study an ancient coral fossil that shows daily growth rings. We count them and find that a year once held more days than it does now. It seems to confirm that Earth's rotation has slowed. Yet we cannot be sure that this fossil is typical. Perhaps the conditions of its growth distorted the rhythm. Perhaps we are missing fossils from other regions that would have told a different story. Our conclusions, then, must remain cautious, aware of the uncertainty built into every trace. The language of traces always speaks with hesitations. Isotopes in ice cores tell us of ancient air, but the chemistry may be altered by pressure. Sediment layers show cycles, but floods or earthquakes can erase them. Even our modern atomic clocks, so precise, reveal their limits when compared across great spans of space or gravity. Each method leaves room for doubt. And yet it is within these uncertainties that curiosity grows. Now we can gently try a thought experiment. Suppose time once flowed at a slightly different pace, but the traces it left are scattered. A few fossils suggest it, but others are missing. A few layers in ice hint at irregularity, but compression has blurred them. Our instruments, reaching back only a century or two, are too young to compare. In this case, the shift might remain invisible, hidden by the incompleteness of evidence. Now imagine another possibility. Suppose time has always been steady, but natural processes, erosion, pressure, biological variation, create irregularities in the records we study. The result is the same: uncertainty, ambiguity, patterns that whisper but never shout. We cannot say for sure whether time changed or whether the traces are only imperfect reflections. The truth may be beyond our reach. What we can do is rest with humility. To explore time is to accept that our knowledge is always partial, stitched together from fragments. Gaps are not failures but part of the landscape. They remind us of the scale of what we are studying. The Earth has turned for billions of years, while our instruments have measured only a breath of it. Against such scale, silence is inevitable. And so the cautious conclusion is this: the limits of evidence do not close the question of time but open it further. We live inside a mystery, guided by traces but surrounded by uncertainty. To sit with that awareness is not to be unsettled but to find calm. For uncertainty is not chaos. It is simply the space where knowledge has not yet reached. In that space we may rest, knowing that time flows on, whether or not we fully understand its rhythm. What if memory itself, fragile and shifting, is also an archive of time, storing not only events but the rhythm with which they seem to flow? Our personal sense of time comes from how we recall days, seasons, and years. Yet memory does not measure like a clock. It stretches, compresses, and sometimes erases. A summer of childhood may feel endless, while years in adulthood slip past quickly. In this way, the human mind becomes both participant in time and its own recorder of changing pace. Now we may pause to consider how memory works in simple terms. Experiences are not stored like pages in a book. They are more like patterns woven into a tapestry, strengthened when repeated, faded when neglected. Strong emotions, striking events, or steady routines shape how much space an experience takes in memory. This means that time as remembered is not equal to time as lived. Days of routine may blend into one, while moments of intensity expand, lingering far longer. Over generations, such distortions accumulate into collective memory, legends, histories, traditions that carry a community's sense of time. But here we must be cautious. Memory is selective. It is shaped by culture, by repetition, by what is told and retold. The absence of certain events in collective memory does not mean they did not happen. It only shows how fragile human archives can be. Oral traditions may lose detail. Written records may preserve only what seemed important to those in power. What remains is a partial, sometimes distorted reflection of time's flow. Yet even this partiality is revealing. It shows us that time as experienced by humans has never been steady, but elastic, bound to perception. Now let us pause on the language of traces in memory. A diary written centuries ago may tell us that a season felt unusually long or short. Folklore may recall a great winter or years of hunger, describing not just events but how time itself weighed on people. Archaeological records show shifts in settlement patterns, suggesting that groups remembered cycles of plenty or scarcity and moved accordingly. Statistical records, when they appear, reflect the same: fluctuations in harvests, in lifespans, in calendars. These are not direct measures of time, but indirect signs of how communities felt its pace. Now a gentle thought experiment. Imagine two generations living through different rhythms. One grows during a time of peace and abundance, where days are filled with steady routines. Their memory of life is spacious, perhaps even slow, each year filled with repetition. The next generation grows during turmoil, with sudden changes, migrations, or disasters. Their memory is marked by intensity, events crowded together. For them, time feels compressed, life rushed. Neither group is wrong. Their experiences shape how time itself is remembered. Now imagine that centuries later, historians look back. The records of the peaceful time are few, because little seemed worth writing. The records of turmoil are many, because everything seemed urgent. To future readers, the rhythm of history appears uneven, some periods thick with time, others thin. Yet this is not a record of time itself changing, but of memory's selective weight. We must accept this limitation with humility. The archives of memory, whether personal or collective, do not measure evenly. They highlight, compress, erase. Absence of proof is not proof of absence. What feels like silence in history may be only the quiet of forgotten days. And so the cautious conclusion is that memory, both individual and cultural, is one more way time reveals its elasticity. It is not an external measure, but an internal rhythm, one that shapes how we live and how we recall. To rest with this thought is to see that time is not only outside us, in stars or stones, but also within us, shaped by what we notice and what we forget. In this way, memory becomes a mirror of time's flow, fragile yet enduring, uneven yet deeply human. What if great catastrophes of the past did more than shape landscapes and life, but also altered the rhythm by which Earth seemed to measure its own time? Asteroids striking the surface, supervolcanoes releasing vast clouds of ash, even sudden shifts in the planet's core. Each event carried energy so immense that it may have nudged the delicate balance of rotation, orbit, or atmosphere. The question is not whether such events happened, for we see their traces in craters, ash layers, and magnetic shifts, but whether their influence on time was greater than we usually imagine. Now we may pause and consider the context. Earth's orbit around the Sun, its spin on its axis, and the tilt that gives us seasons are not perfectly stable. They are influenced by gravity from the Moon, from other planets, and from internal dynamics. A large impact, for example, delivers both mass and momentum. The energy can be enough to change the tilt of the axis or to alter the length of a day, if only by the smallest fraction. These fractions may be imperceptible to us, but across millions of years they become part of the rhythm written into rocks and fossils. The mechanism is simple in essence. A spinning object, like Earth, keeps its motion unless disturbed. When an asteroid collides, even at great speed, it can slightly speed up or slow down the rotation, much like a hand tapping a spinning wheel. Volcanic eruptions act differently, not by striking from outside, but by filling the atmosphere with particles that reflect sunlight. This changes climate, which changes ice and water distribution, which in turn shifts the balance of Earth's rotation. The processes are indirect, yet still connected to the passage of time as we measure it. Here we should acknowledge the limits of what we know. Our direct records of rotation length span only a few centuries, measured first by astronomy and more recently by atomic clock. Older evidence is indirect, drawn from corals, sediments, and astronomical calculations. Gaps are many and signals are faint. Absence of evidence is not evidence of absence. It simply reminds us that traces of ancient shifts are often buried or erased. Still, the language of traces is there. Layers of iridium in rocks tell us of an asteroid impact 66 million years ago, the event that coincided with the end of the age of dinosaurs. Ash deposits show us supervolcanoes that dimmed the skies for years. Magnetic layers in rocks record sudden flips in the Earth's field, perhaps linked to changes deep within the core. None of these prove that time itself changed, but each shows a moment when the usual rhythm of Earth was disturbed. Now let us try a quiet thought experiment. Imagine Earth struck by a large asteroid. The days that follow are filled with dust and fire. The spin of the planet slows by a fraction, so that each day is longer, though no living being notices directly. Over thousands of years, this small change accumulates, recorded in corals and sediment. Future creatures, long after, may read these archives and see that something once bent the rhythm. Now imagine another scenario. A supervolcano erupts, spreading ash across continent. The skies dim, seasons blur. Ice sheets grow, oceans shift, and the balance of the planet changes slightly. The length of a day adjusts by tiny increments, imperceptible but real. Centuries later, when the ice melts and oceans return, the balance shifts again, and time's rhythm readjusts. These thought experiments are not certainties, only reminders of possibility. The cautious conclusion is that great catastrophes may leave more than scars in rock or fossils. They may also leave faint imprints in the very rhythm of Earth's spin and orbit, subtle changes in the way days and years unfold. We cannot prove this beyond doubt, but we can remain open to the idea that time, as measured by Earth, is not immune to sudden events. To rest with this thought is to see the planet not as a perfectly steady clock, but as a living body, sensitive to shocks and adjustments, carrying both continuity and change. In that softness, we are reminded that time, like Earth itself, may be both fragile and enduring. What if the deep interior of the Earth, unseen and unreachable, has been quietly shaping the tempo of days and nights? Beneath our feet lies not a solid, still core, but a dynamic heart of molten metal and shifting flows. The outer core, a sea of liquid iron, moves and swirls, generating Earth's magnetic field. The inner core, dense and hot, may rotate at a slightly different speed than the surface above. These hidden motions affect not only magnetism but also the rotation of the planet itself, which is the foundation of how we count time. Now we may pause and picture this simply. When a skater spins and shifts their arms, the speed changes. The Earth, too, redistributes its mass. Flowing magma, rising plumes, even the movement of tectonic plates alter the balance. These adjustments are tiny from our perspective, often no more than milliseconds in the length of a day. Yet they accumulate, and the result is that time on Earth has never been perfectly steady. The mechanisms are subtle. Heat rising from the core causes convection, moving liquid iron in vast loop. These movements interact with the mantle above, transferring energy, nudging the planet's rotation. Earthquakes also play a role, redistributing mass in sudden jolt. After a great quake, scientists can measure days shortened by a fraction of a second. We cannot feel it, but the clocks reveal it. Here we must be cautious. Our direct measurements span only a few decades of precise instrumentation. Older evidence comes from astronomical observations. Records of eclipses written centuries ago, compared with modern predictions. These reveal that Earth's rotation has varied, sometimes faster, sometimes slower. The causes are many: tides, atmosphere, core dynamic. To separate them is difficult, and so our conclusions remain tentative. Still, the language of traces is there. Ancient Chinese and Babylonian eclipse records, compared with modern models, show that the timing does not align perfectly unless we account for changes in Earth's rotation. Geological layers that capture tidal patterns also reveal slight variations, suggesting that the spin of Earth has been inconsistent across ages. Together, these traces form a quiet but steady message. Time, as measured by the turning of the Earth, has always carried small irregularities. Now let us linger with a thought experiment. Imagine a time when the inner core rotated a little faster than the mantle above. Over centuries, this difference subtly changed the length of a day, adding milliseconds unnoticed. Creatures of that age lived by dawn and dusk as usual, yet the rhythm of time itself was gently altered. Now imagine a great redistribution of mass as continents shift and oceans deepen. The spin adjusts again, not suddenly but persistently. Days lengthen or shorten, the measure of a year shifts slightly. Over millions of years, these differences compound, leaving imprints in the archives of fossils, sediments, and records of eclipses. These thought experiments remind us that even without cosmic forces, Earth itself has been a variable clock. Its molten heart, its trembling crust, its shifting oceans all contribute to small adjustments in the rhythm we live by. The conclusion must remain careful. We cannot claim that time itself changes, only that the way we measure it through Earth's spin is never perfectly even. The archives of eclipses, the layers of rock, the precision of atomic clocks all confirm this. What seems to us a steady march of seconds is, in truth, a rhythm with tiny hesitations and accelerations. To rest with this thought is to feel the planet as alive, not only in its surface but in its deepest heart. Time, when tied to Earth, is not the rigid tick of a perfect clock, but the breathing of a living world, sometimes quicker, sometimes slower, always moving quietly forward. What if the rhythms of time have also been shaped by forces far beyond Earth, by the slow dance of the solar system itself? Our planet does not spin and orbit in isolation. It is part of a system where every planet, every moon, every fragment of rock contributes, however faintly, to the gravitational web. Over immense spans of time, these interactions create cycles in Earth's orbit and tilt, known as Milankovitch cycles. They unfold not in years or centuries, but in tens of thousands, even hundreds of thousands of years, altering the climate and perhaps the way time itself feels when recorded in natural archives. Now we may pause and unfold these cycles in simple words. Earth's orbit around the Sun is not a perfect circle. It stretches and contracts slightly over cycles of about 100,000 years. This is called eccentricity. At the same time, the tilt of Earth's axis, which gives us seasons, wobbles slowly like a spinning top. This tilt varies over about 40,000 years. And alongside these, the direction in which the axis points, its precession, rotates over a cycle of about 20,000 years. Together, these changes alter how sunlight reaches different parts of Earth, shifting the rhythm of seasons and the balance of climate. The mechanism is gentle but powerful. A slightly different tilt can make winters colder and summers hotter, or the opposite. Over thousands of years, such changes accumulate, building ice sheets or melting them away, creating cycles of glacial ages and interglacials. In this way, cosmic mechanics leave their mark on the planet's rhythm, and through that, on the archives we later read. Here we must acknowledge limit. These cycles are well modeled and confirmed in broad strokes, but the details are often blurred. Ice cores, sediments, and fossils show repeating patterns, yet they do not always align perfectly with the cycles we expect. Climate is influenced by many factors: volcanoes, greenhouse gases, ocean current. Absence of exact alignment does not mean the cycles are absent. It only means that Earth is more complex than a single clockwork. The language of traces here is striking. Deep-sea sediments reveal repeating layers of light and dark material tied to the waxing and waning of ice sheet. Ice cores record swings in temperature and greenhouse gases that mirror orbital rhythms. Fossils of tiny ocean creatures, preserved in sediments, show chemical changes that match the cycles of sunlight over ages. These are indirect, yet together they form a chorus, suggesting that cosmic rhythms have shaped Earth's sense of time. Now let us try a quiet thought experiment. Imagine we are part of a community living during a glacial maximum, when vast ice sheets cover much of the northern continents. Days and years pass as usual, but the seasons feel harsher, winters longer, summers short and weak. For those alive then, time feels heavy, marked by endurance. Now imagine many thousands of years later, in an interglacial period like our own. The same cycles have shifted, sunlight falls differently, and the climate is softer. Days still hold 24 hours, but life flows with more abundance, the rhythm of time feeling lighter. Finally, imagine far ahead, when the cycles once again bring colder summers, allowing ice to grow. The slow cosmic clock ticks on, changing not the seconds of the day, but the broader tempo in which life unfolds. The cautious conclusion is that the solar system, in its vast gravitational dance, acts as a slow metronome for Earth. It does not alter time itself, but it shifts the context in which time is lived and remembered. Traces in sediments and ice whisper that Earth has long been swayed by these cycles, though never in perfect predictability. To rest with this thought is to sense our planet as part of a greater rhythm, one where days and nights are nested within seasons, and seasons within cosmic cycles. Time, seen this way, is layered, patient, and deeply connected to the motions of the heavens. What if the stars themselves, steady points in our night sky, have been quiet witnesses to the changing rhythm of time on Earth? For thousands of years, people have looked upward, tracing constellations, following the slow drift of planets, and marking the rising of bright stars as signs of seasons. The heavens have always seemed eternal, yet even they move with subtle shifts, and in those shifts lies another archive of time. When we look at the night sky today, we see it as it is now, but also as it was. Starlight travels vast distances, taking years or even millennia to reach us. Each star is a messenger from the past, carrying not only its own light but the rhythm of the universe it moved through. And as Earth turns beneath that sky, our own clocks are tied to its movements, the spinning of the planet against the background of constellations. Now let us pause on the mechanism. Stars appear to rise and set because of Earth's rotation. Over centuries, their positions shift slightly in a process called precession. The axis of Earth wobbles like a slow spinning top, completing a cycle in about 26,000 years. This means that the fixed stars are not fixed at all, but drifting gently through the patterns we think of as eternal. For ancient builders of monuments and calendars, this drift mattered. A star that once marked the solstice sunrise might no longer align after a few centuries. For us, it is a lesson that even the most steady rhythms are not truly steady. The evidence for this comes from the language of traces. Old records of star positions, carved into stone or written on clay tablets, do not match perfectly with today's sky unless we account for precession. Alignments of monuments that once faced a particular rising star now point slightly aside. The gap is not error, but signal, proof that Earth's axis has wandered, stretching the rhythm of time in a way too slow for any one life to notice. Here we must be cautious. The archives of the sky are indirect. Stories of constellations change with culture. Ancient records may exaggerate or misinterpret. Absence of clear alignment does not mean absence of intention. Yet when many records, across continents and centuries, show the same slow drift, we can gently conclude that time, as measured against the stars, is layered and shifting. Now let us try a thought experiment. Imagine we live in a desert thousands of years ago. Each year, the rising of a bright star at dawn tells us when to plant. Generations follow this rhythm, trusting its certainty. Yet slowly, over centuries, the star rises later, drifting out of alignment with the seasons. The calendar grows less certain. For us, it feels as if time itself is slipping, as if the universe has changed its pace. Now imagine a far future, when our descendants watch other stars rise in places where none appear today. For them, new patterns will define time, while the old constellations have broken apart. To them, time may feel as though it has always flowed this way, unaware of how different the sky once was. The cautious conclusion is that the stars remind us of the scale of time. They move too slowly for one life to measure, but their archives, preserved in records and monuments, whisper of changes larger than human memory. Time, seen through the sky, is both constant and shifting, steady in its daily rise and fall, yet elastic in its slow drift across ages. To rest with this thought is to sense that our clocks, no matter how precise, are only echoes of a larger rhythm. The heavens are patient, moving on scales beyond our lifetimes, yet they leave traces for us to read, if we pause long enough to listen. What if the quiet rhythms of life itself, carried in the growth of trees, corals, and shells, have been subtle witnesses to the flow of time on Earth. In the rings of wood, in the layers of calcium laid down by marine creatures, and in the steady growth of reefs, we find natural records that stretch across centuries and sometimes millennia. These living archives are not clocks in the mechanical sense, yet they keep a rhythm tied to seasons, to cycles of light, to the turning of the earth. And in their patterns, perhaps, are traces of how time has never been entirely even. Let us pause with trees, which grow a new ring each year. In warm seasons the wood is lighter, in colder or drier seasons it is darker. Counting these rings tells us age, but more than that, it tells us of the conditions in each year. A narrow ring may mark drought, a broad ring abundance. When rings from many trees are compared, they form long sequences, stretching back thousands of years. These dendrochronological archives not only tell us of climate but also provide a rhythm, an annual pulse of Earth. Yet sometimes the rings do not fit perfectly. They skip or double or blur. These small irregularities may reflect stresses, but they also remind us that even nature's clocks can falter. Corals, too, leave behind rhythms. They build their skeletons in fine bands, day by day and year by year, recording cycles of light and tide. Fossil corals show us that hundreds of millions of years ago, days were shorter, years longer, because Earth's rotation has slowed since then. The corals did not know they were keeping time, yet their patterns became an archive of planetary rhythm. Shells and other marine creatures also carry similar records, their layers recording tides, temperatures, and sometimes irregularities that speak of changes larger than themselves. Here we must be cautious. These natural clocks are not perfect. Trees may fail to grow rings in harsh years. Corals may be broken by storms. Shells may dissolve or be buried before their record is complete. The absence of evidence does not mean that nothing happened. It only shows that archives are vulnerable, subject to silence. Still, when enough records are compared, the patterns emerge, whispering of long rhythms in climate and time. Now let us imagine gently. Suppose we stand in a forest thousands of years ago. A tree grows slowly in the dim light of a colder age, its rings narrow, its growth hesitant. Centuries later, the climate warms and its rings widen. To the people who live among these trees, the years pass as usual, yet the trees are quietly measuring a shifting rhythm of time. Now imagine in the ocean, corals building reefs under a different sky. Their daily bands reflect shorter days, their annual cycles more numerous within a year. If we were to look back now, we would see that their growth recorded a tempo of Earth that felt ordinary to them but seems uneven to us. These thought experiments remind us that life is a participant in time as well as a recorder of it. The cautious conclusion is that biological rhythms are among the most delicate archives of Earth's history. They show us not only how life responded to changes in climate and rotation but also how time itself, as measured through natural cycles, may have stretched and shifted. They are not precise clocks, but they are patient witnesses. To rest with this thought is to see that time is not only written in rocks or stars but also in the fragile and persistent growth of living things. Rings, bands, layers, each is a whisper of the rhythm of Earth, steady yet never perfectly even, an organic memory of how life and time have always grown together. What if even the smallest particles of the universe, invisible to our eyes, have been carrying secrets about the nature of time? At scales far smaller than we can sense, the world of quantum physics behaves in ways that seem to loosen the threads of ordinary rhythm. Here, particles can exist in more than one state at once, or appear connected across distances in ways that defy our everyday logic. Within this strange realm, time does not always flow in the straightforward way we expect. Now we may pause and place ourselves within context. Our daily timekeeping relies on large, steady motions, the turning of the Earth, the orbit around the Sun, the swing of pendulums, the vibration of crystals. Yet the most precise clocks we have today are not pendulums or crystals, but atoms themselves. Atomic clocks use the natural vibrations of atoms, such as cesium or strontium, as their measure. These vibrations are astonishingly consistent, repeating billions of times per second, allowing us to keep time with unmatched precision. But at the quantum scale, even these rhythms can shift depending on conditions, reminding us that time is bound to the laws of physics rather than to absolute certainty. The mechanism is subtle. In relativity, time slows when gravity is stronger or when speed increases. Atomic clocks confirm this. A clock on a mountain ticks slightly faster than one at sea level because gravity is weaker higher up. In airplanes, time stretches differently again. These variations are tiny, but they are real. At the quantum level, experiments suggest even stranger possibilities. Some interpretations of quantum mechanics hint that time may not be a fundamental ingredient but something that emerges from deeper processes, like a melody arising from vibrations rather than an independent note. Now we should pause on the limit. These ideas remain uncertain. Physics at the smallest scales is full of competing theories. Some experiments show hints, but none offer a complete picture. Absence of proof does not mean time behaves differently in absolute terms. It only reminds us of how little we know. Still, the language of traces is there. Data from atomic clocks, when compared across altitudes, reveal measurable differences. Observations of particles decaying at high speeds show time dilation, matching predictions of relativity. Statistical patterns in quantum experiments suggest that time, at least as we understand it, may be an approximation of deeper processes. These are faint markers, glimpses rather than proofs, but they guide us carefully forward. Now let us linger with a thought experiment. Imagine we shrink ourselves to the quantum scale, where particles flicker in and out of state. What feels to us like a second may not exist there at all. Instead, processes unfold without a clear before and after. Now imagine that time itself is not constant but emerges differently in different regions of the universe, depending on the balance of matter, energy, and quantum rules. Over great spans, these differences might ripple upward, subtly influencing the way stars evolve, the way galaxies form, even the way Earth spins. The cautious conclusion is that the quantum world offers hints that time may not be as solid as it seems. It could be elastic, relational, or emergent. We do not know for certain, and perhaps we never will. But by listening to the whispers of atoms and particles, we glimpse the possibility that time, as we live it, is only one layer of a deeper, more intricate fabric. To rest with this thought is to accept the mystery with calm. Our clocks remain steady enough to guide our days, yet beneath them may lie a quieter, stranger rhythm, one we can sense only through the smallest traces. In that awareness, time becomes less a fixed river and more a field of possibilities, flowing gently beneath everything we know. What if time, instead of being a single continuous stream, has always been tied to motion itself, bending and stretching depending on how we move through space? This is the lesson of relativity, a theory that has reshaped our understanding of the cosmos over the past century. It tells us that time is not fixed for all observers but depends on speed and gravity. A clock in orbit ticks differently from a clock on the ground. A clock near a massive star ticks differently from one far away. To us, the difference feels imperceptible, yet the principle is firm, and its consequences reach into every corner of the universe. Now we may pause and think in simple terms. Imagine two friends walking side by side. Their steps are in rhythm, and their watches agree. Now one begins to run, while the other continues walking. According to relativity, the runner's watch would tick slightly more slowly, even though both still feel time moving as usual. At everyday speeds, the difference is unimaginably small. But at speeds near that of light, the effect becomes profound. This slowing of time with motion is called time dilation. It has been confirmed by experiments with fast-moving particles and with precise clocks carried on aircraft and satellite. The mechanism is not magic but geometry. Space and time form one fabric, called spacetime. When movement through space increases, The movement through time adjusts, as if both must balance. Just as a shadow shifts when light changes direction, time itself shifts when speed or gravity enters the picture. But here we must admit the limits. Our direct experience is rooted in slow speeds and weak gravity, so we cannot feel these differences naturally. Only instruments, atomic clocks, particle detectors, astronomical observations, make them visible. Absence of sensation does not mean absence of effect. It only shows that human senses were never tuned to cosmic scales. The language of traces here is compelling. Muons, unstable particles created in the upper atmosphere, should decay before reaching the ground. Yet they survive longer because they move near light speed and their time runs slower. GPS satellites orbiting Earth must constantly correct for time dilation, since their clocks tick differently in weaker gravity and higher speed. Without such corrections, navigation would drift quickly out of accuracy. These are quiet but strong signals that time is not the same everywhere. Now let us try a thought experiment. Imagine two travelers leaving Earth in a ship near the speed of light. For them, the journey to a distant star might last only a few years. When they return, however, they would find that centuries had passed on Earth. Time, for them, had stretched differently. Now imagine standing on the edge of a black hole, where gravity is so strong that time slows almost to stillness. To an outside observer, 1 second for us near the horizon could equal years far away. Yet for us, time would still feel normal. The difference would lie in comparison. These thought experiments are not speculation alone. They arise directly from relativity's predictions, tested again and again with growing precision. The cautious conclusion is that time is not universal in the way we once imagined. It bends with speed, with gravity, with context. Our daily lives remain untouched, but the universe itself carries countless versions of now, layered and relative. To rest with this thought is to feel the softness of time, not rigid and uniform but supple, shaped by the fabric of spacetime itself. It is a reminder that what seems steady is only steady in our frame, while the cosmos holds many rhythms, each true within its own path. What if time, instead of being a single continuous ribbon, could sometimes fold back on itself, creating loops where beginnings and endings are not so easy to separate? In theoretical physics, such ideas are not dismissed outright, though they remain deeply uncertain. They appear in discussions of closed time-like curves, mathematical solutions of Einstein's equations where paths through spacetime bend back, allowing the same moment to be reached more than once. To us, accustomed to the steady flow of seconds, such possibilities seem paradoxical, yet they are worth exploring gently, as thought experiments, because they remind us of how little we truly know about time's architecture. Now we may pause and place ourselves in context. When we look at our ordinary lives, time appears linear. We are born, we age, we die. Seasons turn in sequence, never reversing. But at the scale of physics, time is not so rigid. Equations that describe motion often work the same whether time flows forward or backward. In relativity, spacetime itself can curve in ways that challenge our simple notions of direction. And in quantum physics, processes sometimes seem to disregard our sense of order, hinting at a deeper structure where past and future might not be absolute. The mechanisms imagined are difficult but can be described simply. A closed time-like curve is like walking in a circle. One can return to the same point without stepping outside the path. In spacetime, such a curve would mean returning to the same moment in time. The conditions needed are extreme, often involving immense gravity, such as near-rotating black holes, or exotic matter with unusual properties. None of these are accessible to us, but the mathematics suggests they could exist. Yet here we must acknowledge the limit. There is no evidence that such loops exist in our universe. The traces we rely on, fossils, rocks, stars, particles, show no sign of repetition, no sign that time has doubled back on itself. Absence of evidence does not prove impossibility, but it does remind us that if such structures exist, they are hidden or rare. The language of traces here is faint. Astronomical data reveals stable forward motion, not loop. Geological archives show layers that follow one another without reversal. The only echoes we glimpse are in mathematics and in paradoxes of thought. These are not physical markers, but intellectual ones, hints that our equations are more flexible than our intuition. Now let us try a careful thought experiment. Imagine that time is not a straight line but a great circle. As we move forward, we eventually return to where we began. In such a world, the distinction between past and future would blur. Events might repeat, though not necessarily with memory. To those living within the circle, time would still feel like progress, even though its path was curved. Now imagine another possibility. Time remains mostly linear but allows small folds, tiny loops so brief they are imperceptible. Particles could slip through them, returning to their own past by fractions of a second. Such events, if they occurred, might leave statistical traces, anomalies in experiments too subtle to notice easily. Over long spans, these folds could smooth out, leaving no record except in probabilities. These thought experiments do not claim truth, but they open space for reflection. The cautious conclusion is that time, as we know it, appears linear and irreversible, yet mathematics leaves room for stranger possibilities. We cannot confirm them, but their existence as solutions reminds us not to hold our understanding too tightly. To rest with this thought is to accept both the stability of our lived time and the openness of theory. Perhaps time is indeed a straight path, or perhaps it carries hidden bends we cannot yet perceive. Either way, it flows on, steady enough for our days, mysterious enough. What if time itself is not a single thread but one of many, each woven into a greater fabric that we cannot yet fully see? In some interpretations of physics, especially in ideas about the multiverse, our universe is only one among countless others. If so, then perhaps each universe carries its own rhythm of time, slower in some, faster in others, maybe flowing in directions we cannot imagine. To us, bound within one strand, the flow seems absolute, yet in a wider frame it could be relative, just one possibility among many. Now we may pause and settle into context. The notion of a multiverse arises from attempts to explain why our universe has the laws it does. Some theories of cosmology suggest that after the Big Bang, regions of spacetime expanded in different ways, creating separate domains, each with distinct properties. In one domain, gravity might be stronger, in another, the speed of light different. If time is tied to these laws, then its flow too could vary, shaped by the structure of each universe. The mechanism here is abstract, but we can picture it in simple form. Imagine a vast library, each book containing its own story, with its own pacing. In one book, events unfold slowly, in another, quickly, yet each is consistent within itself. The multiverse, if it exists, could be such a library, and our universe is one book. We know only the pacing of our own pages, not how others might unfold. But here we must pause with caution. We have no evidence of these other universes. The traces we search for, cosmic radiation patterns, irregularities in fundamental constants, are at best indirect. Absence of clear proof does not mean the multiverse is impossible. It only reminds us that our reach is limited, our instruments tuned to one universe at a time. Still, the language of traces exists, faint though it is. Some studies of the cosmic microwave background, the afterglow of the Big Bang, suggest anomalies that might be interpreted as collisions with other universes. Variations in the apparent strength of physical constants have been proposed as hints of a broader reality. None of these signals are certain. They are whispers, possibilities that ask us to listen carefully without rushing to declare. Let us try a gentle thought experiment. Imagine that our universe is not alone but one of many bubbles in an endless sea. Each bubble carries its own time, flowing with its own rhythm. Now imagine, for a moment, that two bubbles drift close, brushing against one another. At the boundary, their times would not match. A second in one might stretch to an hour in another. If such contact left a trace, perhaps it would be written in the background of radiation or in subtle distortions of space. Now another step. Suppose beings in another universe looked at us across this divide. To them, our time might appear strange, compressed, or elongated. For us, life feels natural, our seconds steady, our years familiar. Yet in their view, our rhythm would be alien, just as theirs would be to us. This experiment, though imagined, helps us see time not as absolute but as contextual, a property of the place we inhabit. The cautious conclusion is that the multiverse, if it exists, may carry countless versions of time, each flowing in its own way. For now, we live within one strand, measuring only what we can, sensing only the rhythm given to us. To rest with this thought is to accept both the intimacy of our own time and the possibility of larger patterns we cannot yet touch. It is a reminder that our universe may be one voice in a wider chorus, each singing its own tempo, each carrying its own unfolding. What if time, instead of being an external flow that we move through, is something that emerges from memory, from the way matter and life record change? In this view, time may not be a universal container, but a pattern that arises only because events leave traces. Without memory, whether in rocks, in atoms, or in minds, perhaps time would not be felt at all. We may pause and let this thought settle. Our daily sense of time comes from noticing difference. The sun has risen higher, the shadows have shifted, our bodies have grown a little more tired. Memory stitches these changes into a sequence, and we call that sequence time. Without the ability to compare, a moment would not be distinct from another. In physics, too, the flow of time is often tied to entropy, the tendency of systems to spread into disorder. A cold drink warms, smoke disperses, stars burn their fuel. These changes are one way, and so they give us a sense of direction. The mechanism is simple at heart. Entropy increases because there are more ways for matter to be disordered than ordered. A shattered cup has more possible arrangements than an intact one. By following this rule, the universe builds a kind of memory in its very structure. Ashes carry the memory of fire, fossils the memory of life, sediments the memory of rivers. The direction of time is the direction of growing record. But we must pause with caution. Memory is not perfect. Rocks erode, fossils break, sediments shift. Even in our own minds, memories fade or change. The absence of record does not mean the event never occurred. It only means the archive has been lost. Likewise, in physics, entropy is statistical. It does not forbid order from returning, it only makes it unlikely. The arrow of time, then, is not an absolute law but a tendency. The language of traces is clear here. Layers of ice in Antarctica preserve bubbles of ancient air, marking seasons one upon another. Tree rings hold the rhythm of years. Crystals in caves record past rainfall in subtle shifts of isotope. These are memories, imprinted in matter, that make the past distinct from the present. Even at the atomic scale, radiation leaves tracks, particles leave scars in detectors. Everywhere, the universe is writing. Now let us attempt a thought experiment. Imagine a universe where nothing could record change. No rocks to layer, no atoms to decay, no minds to remember. Would time still exist there? Perhaps in equations, yes. But without traces, without memory, it would feel like a constant present, indistinguishable, unmoving. Now imagine our own universe stripped of memory just for a moment. The rivers still flow, the stars still shine, but nothing retains the difference. Every second would collapse into the same instant. The concept of before and after would vanish, not because time itself had stopped, but because its markers had dissolved. One more step. Imagine a world where memory accumulates faster, where every grain of sand, every breath of wind leaves a permanent mark. Time there might feel heavier, dense with record, every moment burdened with its own lasting trace. Life would move through a thick archive, never able to forget. These experiments remind us how deeply memory is tied to time. The cautious conclusion is that our sense of time depends as much on what is preserved as on what passes. The universe writes constantly, but it also erases. We live between traces, reading what remains, inferring what is gone. To rest with this thought is to see time not as a rigid line but as a vast, imperfect memory. Some pages are smudged, some are missing, some are beautifully clear. And it is through these pages, fragile and incomplete, that we feel the flow of what we call time. What if time, instead of being evenly spread across the universe, has always been woven unevenly into the very structure of matter itself? Physics offers us the idea that time may not be separate from the things it touches, but bound into the particles and fields that make up reality. If so, then the flow we feel each day may be only the surface of a deeper pattern, where time is stitched into the very atoms around us. Now let us pause within context. Matter, as we know it, is built from particles, electrons, protons, neutrons, and the fields that guide them. These particles obey rules that are both strict and strange. Among them, there is one puzzle often called the arrow of time in particle physics. Some interactions seem to prefer one direction over another, as if time at the smallest scale leans subtly toward the future. This is not obvious in our daily lives, but it suggests that time and matter are not strangers. The mechanism can be described gently. In most physical laws, if we reverse time, the equations still work. A pendulum swings forward or back, and the math remains unchanged. But in certain cases, such as the decay of particles called kaons or B-mesons, this symmetry breaks. Experiments show that these particles behave differently if time is reversed. This asymmetry is called CP violation, and though tiny, it may be the root of why matter outweighs antimatter in our universe. Without it, the balance might have erased all structure, leaving no stars, no planets, no us. So here, time's direction is tied to the very presence of matter itself. Yet we must acknowledge the limit. CP violation is rare and subtle. Its traces are found only in specialized experiments, invisible in ordinary experience. The exact connection between these microscopic tilts and the vast arrow of time we feel is not fully understood. Absence of clarity does not mean absence of connection. It simply shows us the frontier of knowledge. Still, the language of traces here is delicate but real. Detectors in laboratories measure the decay of particles, capturing data that reveal tiny biases toward the future. Statistical records show asymmetries that would not exist if time were perfectly reversible. The very imbalance of matter and antimatter in the universe may itself be a trace, a fossil of an early tilt in time's flow. These are not dramatic signs, but quiet ones, preserved in data tables, in long sequences of observations, in the survival of matter itself. Now let us step gently into a thought experiment. Imagine a universe where time is perfectly symmetric, where particles have no preference for forward or backward. In such a universe, matter and antimatter might have annihilated completely, leaving only radiation. There would be no galaxies, no planets, no life. In such a place, the very concept of memory and history might never arise. Now another step. Imagine that the bias of time were stronger, that matter's dominance was overwhelming. The universe might have formed more quickly, burning its fuel in a rush, stars igniting and dying in rapid sequence. Time there would feel compressed, not in hours or days, but in cosmic cycles flashing past. And now a final step. Imagine that the asymmetry fluctuated, not steady but varying in different regions. Then time might flow differently across space, faster in some domains, slower in others. To us, within one rhythm, it would feel natural, but across the cosmos, many tempos would play at once. The cautious conclusion is that time and matter may be inseparable. The small tilts in particle physics hint that the direction we experience, the steady push toward tomorrow, may be anchored in the tiniest building blocks of the universe. We do not yet know the full story, But the traces remind us that time is not only a backdrop, but also a participant. To rest with this thought is to see matter itself as memory, each particle carrying a quiet lean toward the future, each atom part of the vast rhythm that makes time real. What if time is not only measured in seconds or years, but also in the way living beings feel its weight? Biology gives us rhythms that differ from clocks, inner cycles that govern when we wake, when we rest, when we grow old. If cosmic time stretches across billions of years, biological time lives within us, quiet but firm, reminding us that life is tied to its own unfolding flow. Let us pause and place ourselves in context. Each organism carries internal clocks, molecular processes that repeat in cycles, such as circadian rhythms. These rhythms are about 24 hours long, aligned with Earth's rotation, yet they continue even when external cues like sunlight are removed. Our bodies, in this sense, remember time, not by counting seconds, but by chemical changes that rise and fall in steady patterns. Plants open and close their leaves, animals shift between rest and activity, humans feel alert or drowsy in tune with these inner metronomes. The mechanism is simple at heart, though delicate. Proteins build up in cells during the day, then break down at night, creating cycles that regulate sleep, digestion, even mood. This is biological timekeeping, a living rhythm layered on top of the cosmic one. There are also longer rhythms, seasonal cycles tied to the tilt of the Earth, lifespans that measure out decades, generational patterns that stretch across centuries. In this way, biology adds texture to time, making it personal, embodied, felt. But here we must pause with caution. Biology does not always keep perfect time. Our internal clocks can drift, reset, or conflict with artificial rhythms, such as the schedules created by modern society. Sleep can falter, aging can accelerate or slow depending on conditions. The absence of a perfect alignment does not mean these rhythms do not exist. It simply shows that time in life is not absolute, but adaptive, flexible, and sensitive. The language of traces is present in every cell. DNA carries records of age, with telomeres shortening as generations of division pass. Bones carry rings like trees, layers of growth that speak of years gone by. Statistical data of lifespans, of fertility cycles, of sleep patterns all reveal the imprint of biological time. These traces are subtle but enduring, written into the very fabric of living matter. Now we may attempt a thought experiment. Imagine a world where biological time ran faster, where life aged twice as quickly. Generations would pass in what feels to us like decades. Civilizations might rise and fall before stars could change their brightness. To those beings, their pace would feel natural, but from our perspective, their history would blur in a rapid cascade. Now let us shift the experiment. Suppose biological time ran slower, where lifespans stretched to centuries, and circadian rhythms extended to days. Seasons would still change, but individuals would carry memories across much longer spans. The world would be filled with patience, each moment less hurried, each cycle drawn wide. A final step. Imagine a place where biological time and cosmic time drift apart entirely, where inner rhythms do not match the world outside. Perhaps days last longer than internal clocks, or shorter. In such a world, creatures would live in constant adjustment, out of step with the sky, marking time by their own bodies rather than by the heavens. The cautious conclusion is that biological time is both a reflection and a filter of cosmic time. It translates the vast, unfeeling march of physics into the intimate rhythms of life. We do not know how deeply the two are connected, but we see the traces in sleep, in growth, in memory, in age. To rest with this thought is to understand that time is not only in stars and stones, but also in our pulses, in our cells, in the quiet unfolding of life. It is the rhythm of being, a gentle reminder that while the universe moves on scales beyond our reach, within us it is felt as breath, as change, as the passage of days that make us who we are. What if time, after all our searching, is not something that can be captured in full, but only approached through layers of traces, each incomplete, each provisional. We have walked through the rhythms of physics, of stars, of matter and life, and yet we find that certainty always recedes. Perhaps this is not a failure, but the natural condition of beings who live within time, unable to step outside it to see the whole. Now we may pause to place ourselves in scale. The universe stretches over billions of years, its archives written in stone, in light, in particles that still travel through space. Against this, our lives last only a few decades, a span too brief to measure cosmic rhythms directly. We rely instead on what is preserved. The faint glow of the cosmic microwave background, the layering of ice and rock, the slow aging of stars. These are our clocks, though they are not built by us, but by the universe itself. The mechanism by which we know time is therefore one of interpretation. We read signals, compare them, and construct narratives. In this way, the concept of time becomes both physical and human, anchored in measurements, but also in memory, in meaning. We cannot be certain that time always flowed as it does now. We can only say that the records we have, the traces we trust, are consistent with such a flow. Beyond that, the unknown remains open. But let us acknowledge the limits with care. The absence of evidence for a different time in the past is not evidence that time has always been the same. Geological and astronomical archives reach far, but not infinitely. They are partial, fragmented, shaped by the conditions that preserve them. Between the records are gaps, and in those gaps we can only imagine. The language of traces, though, is strong enough to guide us. We see isotopes that decay at steady rates, suggesting stability. We see layers that accumulate in predictable order, suggesting continuity. We see galaxies whose light has traveled for billions of years, still showing the same physical constant. These are indirect signs, but taken together they weave a fabric of reliability, one that allows us to speak of time as though it were steady, even as we admit the possibility of hidden bends. Now we may attempt a thought experiment to close gently. Imagine a universe where time has changed its flow, but so slowly that life within never noticed. For billions of years, the seconds stretched or compressed, but beings always adjusted, their rhythms adapting unconsciously. To them, time always felt stable. The only hints would lie in the archives, subtle mismatches waiting for careful minds to read them. Now take another step. Imagine a universe where time shifted suddenly, a deep change in rhythm. Life before the shift would leave records that no longer matched the new order. Fossils might appear out of sequence, stars might burn in ways that seemed impossible. To those who came after, it would feel like a puzzle, as though history had folded strangely. And finally, imagine that time has always been what it is, steady and uniform, unchanging since the beginning. Then all our doubts would be like ripples on the surface of a still pond, reflections of our limited view rather than features of reality itself. The cautious conclusion is that we live within a flow that appears stable, though we cannot prove it beyond all scales. Our task is not to claim certainty, but to keep reading the traces with humility, knowing that time is both intimate and immense, both familiar and mysterious. To rest with this thought is to accept that time is not only something to be measured, but also something to be lived, quietly, moment by moment. It is the vast river in which we drift, the archive in which we are written, the rhythm that makes us and carries us forward. If this rhythm feels close to us, if its gentle unfolding brings comfort, then perhaps we already know what to do. Simply let it carry us, softly, into the next moment.